Magic 8 Ball, I have a question for thee. Aren't titrations fun? That cat gets around. Anywho, let's do a quick recap. Last lecture, we talked about titrations, where we add a standard solution known as a titrant, typically a strong acid or base when we do acid-base titrations, and we add that titrant to an analyte, something that we're interested in studying. We learned about making a titration curve, which is a graph that shows how the pH of our analyte solution changes as we add more titrant. I also want to quickly bring up some ideas about buffers that are going to be relevant for the weak acid strong base titration that we're going to do later, which is that a buffer can be created by neutralizing a weak acid or base and forming its conjugate. This will happen during the titration process. And also, for a buffer to effectively regulate pH, the pKa of the acid part of the buffer and the pH of the solution should be within a unit of 1. And this is based on the idea that the ratio of base to acid in the conjugate pair needs to be within 1/10 to 10 times each other. Now, this is just a summary of all the different points that we learned about when we talked about a strong acid being titrated by a strong base. Look at how many ideas are already present in just this type of titration. Calculating the pH of a strong acid or base, looking at a neutralization reaction, and what the pH is of a neutral solution. When we start talking about titrating a weak acid, we'll also bring in how Kas and Kbs relate to the pH of weak acids and weak bases. We'll also bring in buffer solutions. So we really needed that comprehensive overview of all that acid and base theory to understand our titrations. And we need to understand titrations because they're a standard analytical technique to learn about our two questions. What do we have and how much? So let's see how we do that. Now this clicker is important, so I'm actually going to cover it in the video lecture as I have sometimes in the past, but we'll still bring it up in Zoom. So in this question, we have two different acids being titrated by a strong base and their accompanying titration curves. The question is, which of these curves represents a strong acid being titrated? The left, right, neither, both, or it's impossible to tell. Pause the video and give yourself a minute to try to figure this one out on your own. So the answer is B. And I'll explain that now, and then we'll write it down momentarily. So I know it's B because I'm looking at the steep region where the equivalence point is found. And the equivalence point is technically found at wherever this jump is at its sharpest slope, which requires a derivative plot. In this class, we won't go that far. We're just going to go with the estimate that it's in the middle of the sharp region. We can see that in the middle of the sharp region for this curve, the pH is 7. In other words, it's neutral. That is a key indication that the acid and base were both strong because we're left with nothing but water at the equivalence point. We covered that idea in the previous lecture. On the left side, it's actually a weak acid being titrated because the equivalence point has a pH above 7. We'll get into why that happens with a weak acid later. You might have thought that this is the stronger acid though, since its initial pH is more acidic than the strong acid. Try to think of a reason why a weak acid would somehow have a more acidic starting pH than a strong acid. We'll cover that in Zoom. For now, let's just write some key points down. We'll call this analyzing the curve. Analyzing curve. And we'll say in parentheses that we are using our clicker as an example. Using clicker as example. So, our two questions are, what do we have and how much? So let's first talk about what we have, IDing the acid. We just covered that in the clicker. When the pH at equivalence point, is equal to 7, it's a strong acid and a strong base. titration. Now, which strong acid goes with that curve that we saw in the clicker is unclear. To figure out if it's HCl or HI or HBr, we would need to use a different analytical technique, like some of the ones that we'll be learning about later in this course. As for the other analytical question, how much of something do we have? Let's learn about how we could figure out the formal or initial concentration of our acid. Formal concentration of our acid, specifically our strong acid. And by identifying that we have a strong acid, we know that this is what happens. Our strong acid, whatever it may have been, dissociated 100% into protons and some ineffective weak conjugate base. And when we learned about how to calculate the pH of a strong acid way back when, we wrote that whatever the initial or formal concentration is of the strong acid before dissociation, it is equal to the H+ that's in solution after dissociation. And in turn, that's the concentration of protons that are in solution before the titration begins. Before titration begins, i.e. what we labeled as point A when we learned about the titration curve. And we know what the pH was at point A, it's 4. And we know how to convert from pH back to concentration. We just do 10 to the negative pH value. So it's just 10 to the minus pH of point A in the curve, which in our example clicker was 10 to the minus 4, which in turn tells us that our concentration is 1 times 10 to the minus 4, just to put it in scientific notation, and our concentration is molarity. And so there we have it, identification and quantification of an unknown acid. But what if the situation was reversed and we had a base that we wanted to learn about? Well, then we would titrate that base with a strong acid, and if the base was strong, we would see the exact opposite of what we observed the other way. We would start with a high pH, we would then neutralize to equivalence. The pH would still be 7 at the equivalence point, because it doesn't matter which one's the titrant and which one's the analyte. At equivalence point, we have equal amounts of acid and base. They will neutralize, we'll be left with water, pH is 7. Beyond that, we'd keep on adding acid, there'd be no base left to react with, and so the pH would plummet downwards. And so for reference, the way that this syncs up with the different regions of our strong acid being titrated by a strong base, I refer you to slide 7 of this PowerPoint. But if you really understand the logic of the titration that we went through in detail, this should be completely doable on your own. And it's a good exercise to make sure that you totally understand everything that was going on here.